All right, so let's pick up where we left off. We've talked about amplitude and period and how those affect the graph. Let's get into phase shift and vertical shifting and how those are going to add on to what we're doing. So quick refresher here, phase shift is always, you can calculate it by doing C over B, and it's always opposite whatever the sign is, right? So if it's minus 2 pi over 3, for example, we're actually going to move it to the right. The difference with phase shifting is this affects where we're going to start our x value. So in the previous examples, notice we always started our x values at 0, the x values, right? So long as there's no phase shift, x always starts at 0. But if you have a phase shift, that shifts the graph left and right. So when we do our key values, we're going to start our table at whatever the phase shift is. That's the new thing we're adding on. Let's go through and identify the amplitude and the period just like we've been doing. So A, let's do the A value. A is 4 in this example. The period, remember it's 2 pi over B. So in this case, B is the 2. So 2 pi over 2. So the period is just pi. And then the phase shift. So in this example, we do have a phase shift. The C value is 2 pi over 3. So using this formula, it's going to be 2 pi over 3 over 2, right? B is 2. So if you flip it and multiply by the reciprocal, of course, those 2's will zero out or divide out rather. So that leaves me with a phase shift of pi over 3. And because it's minus, it's actually to the right. So it's going to start out, so our table, the difference is our x values are going to start out at pi over 3. Had this been to the left, we would have started out at negative pi over 3, but it was to the right, so we'll start out at positive pi over 3. And then to get the rest of the x values, we're still going to use the quarter period method. So the quarter period, remember, we take the period and we multiply it by 1/4. So in this case, my quarter period is pi over 4. Now here's where you've got to be really comfortable with working with fractions, because I have to add to get this next point. It's going to be pi over 4 units later, right? So I have to add pi over 4 units to the pi over 3 that I'm starting with. So let me just come down here and do that real quick. So pi over 3 plus pi over 4. Common denominator, of course, is 12. So this will be, let's see, 4 pi over 12, right? And then this will be 3 pi over 12, right? So that means my next value would be 7 pi over 12. So 7 pi over 12 is the next x value. Now, I'm adding my quarter period again. Now, my quarter period was pi over 4, but remember that was equivalent to 3 pi over 12. So what you're literally going to do is you're going to add 3 pi over 12 again, right? I'm sorry, it's a little messy. I'm going to add 3 pi over 12 again. So the next key value is going to occur at 10 pi over 12. And this is why I say don't reduce these. It just makes it so much easier if you don't reduce. Let me zoom in a little bit. So 10 pi over 12. The next key value, add 3 pi over 12 again. The next key value would be at 13 pi over 12. Add it again. You would be at 16 pi over 12. Add 3 pi over 12 again. You'd be at 19 pi over 12. Add it again. You'd be at 22 pi over 12. So other than the numbers being a little bit strange, the pattern is consistent. Now you keep adding 3 pi over 12 each time because 3 pi over 12 is your quarter period with that common denominator that we needed to get. Add 3 pi over 12 again, that puts you at 25 pi over 12. One more time to get 2 complete cycles, that puts me at 28 pi over 12. All right, so that's how we get our x values. Now the y values, you need to look at, are you dealing with sine or cosine? So remember, if you're dealing with sine, we're going to start it at 0. And then we're going to go up to a. So a is 4. So remember the pattern. 0, 4, 0, negative 4, 0. That would be one cycle. So 0, 4, 0, negative 4, and 0. And those are going to be the points we're going to use to make our graph. All right, so let's put everything together. We're going to start out at pi over 3. The next key value occurred at 7 pi over 12, and then at 10 pi over 12, and then 13 pi over 12, 13 pi over 12. And again, I know these numbers look a little weird, but just follow the pattern. You're following the pattern every time, you'll be okay. Let's do one more. Okay, so our maximum value was at 4. Our minimum value was at -4. Pi over 3, the value we start out is 0. And then we go up to 4. 0, -4. And, oh, let me get rid of this so it's a little bit cleaner. Let me get rid of all this junk. Sorry about all the coughing. Hopefully you can understand me still. 0. Okay, so because we had that phase shift to pi over 3, and then our graph started out at pi over 3. So there we go. So there's one cycle. Whoops. Try to hook that back through there. There we go. So there's our second cycle. So you can see that because we started out pi over 3 units to the right, there it is. That's where our graph is starting out. Now, originally, the idea is with the original sine curve. Let me see if I can do a different color here. Well, I'm not sure I do a color. That's all right. Our original sine curve would have looked something, something more like this. So it would have started out here, but in this case, it starts out here because of that phase shift. That's the reason that's occurring, okay? So we've got that phase shift to the right of pi over 3 radians. All right, let's talk about the vertical shift. So the vertical shift adds just one more component, and that literally just shifts the graph up and down. What I would do if you have a vertical shift at the end, like this number, is I would just save it till the very end, and I would add an extra row to your table. And I'll show you what I mean here. Everything else, though, is the same. So let's just go ahead and start out with the A value. A, this example is 3. And then the period would be 2 pi over B. In this case, B is 1. So period is just 2 pi. All right. Let's see. Let's do the quarter periods. So the quarter periods are going to be 2 pi times a fourth. So in this case, that would be 2 pi over 4, or just pi over 2. This graph, notice, does not have a phase shift, right? There's no parentheses. There's no C value. But there is a vertical shift. So the vertical shift is down 1, but we're going to come back to that later. Let's do the vertical shift last. Let's get all our key values first. So since there's no phase shift, my X value is going to start out at 0. And then the next key value would be pi over 2 because of the quarter period. And then pi, let's not reduce. Let's do 2 pi over 2, 3 pi over 2, 4 pi over 2. Right, I'm just going up by pi over 2 units because that's the quarter period. Then 6 pi over 2, 7 pi over 2, and then 8 pi over 2. All right, so now let's go ahead and do the y values without the vertical shift first. This is cosine, so we would start at whatever a is when we're dealing with cosine. So a would be 3, 0, -3, 0, 3, 0, -3, 0, 3. And then what I would do is add one more row for the vertical shift. So literally what you're going to do, because it's -1, so the vertical shift is down 1 unit, literally subtract 1 from each of these y values. So we're going to start out at 2, -1, -4, -1 again, right? It's going to follow the pattern. And then, let's see, 2, and then -1, -4, -1, and 2. So literally it takes everything and shifts it down 1 unit. All right, so let's get our X values. So pi over 2. I'm going to go ahead and reduce these now. Pi, 3 pi over 2. Why I reduced some of them and not the others, but that's okay. You get the idea. You don't have to reduce any of them. All right. So we're just going to graph the vertical shifting. So my highest value, my maximum value is now 2, and my minimum value is -4. So we're going to start out up here at 0, 2, and then let's go ahead and put the -1 here. So -1, and then -4, -1, back to 2, -1, -4, -1, and then 2. So it's going to look like this. There's one cycle. If we had graph paper, this would look a little bit more consistent, but that's all right. You get the idea. There's the other cycle. So how does this differ from the original curve? If we were to have looked at the original curve, the maximum would have been at 3, and the minimum would have been at -3. So the original curve would have looked something like this. All of these points literally would have been shifted up 1 unit, right? So the original graph, just to give you an idea, and I'm not expecting you to graph this, but just to give you an idea of how the original graph would have looked, would have looked exactly the same. The period would have been the same. The amplitude would have been the same. Still an amplitude of 3. The distance between the x, or the line of symmetry, I should say, and the peak value is still 3. The line of symmetry is here at -1 now because of the vertical shift. But do you see what I mean? The dashed one is what the original one would have looked like. So we've taken that and literally just shifted it down, the whole thing down 1 unit. And that's all this row does for us. Let's do one more. There's 2 examples here. This one has some funky numbers in it. Let's do number 5, where it only says to go over 1 period this time, but this has everything in it, all 4 elements we've talked about. So let's go ahead and do one where we have everything combined. So start out with your A value. A is 4. The period is 2 pi over B. Notice that B is 3. Period is 2 pi over 3. The phase shift is C over B. So C is pi over 3 over B, which is 3 again. So when you flip that, multiply by 1/3, I get a phase shift of pi over 9. And this is going to be to the left. It's got a vertical shift of down 2 units. And then let's get the quarter period. So the quarter periods, this has got some crazy numbers here, but that's all right. Let's handle it. Quarter period, we're going to take the period. We're going to multiply it by 1/4. So that gives me 2 pi over 12. I'm going to go ahead and reduce that and make it pi over 6. All right. So let's talk about where this is going to start. So because the phase shift is pi over 9, and notice it's to the left, that means we're going to start out at negative, instead of 0, we're going to start out at negative pi over 9, because this was to the left. Remember, it's opposite whatever the sign is. It's going to start out at negative pi over 9. Now, to get the next key value, I have to add the quarter period. Here's where I want you to write this on your paper. I want to see this work on your paper because I don't want you to mess this up. You've got to get a common denominator. So I'm going to take negative pi over 9, and I'm going to add the quarter period of pi over 6. So let's see. The common denominator between 9 and 6 would be 36, I guess. I'm trying to think if there's anything lower. I guess it'd be 36, right? 9 times 4 would be 36. So let's do that. So if we multiply this by 4, let me write it down here. We get negative 4 pi over 36. Multiply this by 6. We get 6 pi over 36. So when I add those together, I get 2 pi over 36. Here's why I say do not reduce this, because I'm going to use this 6 pi over 36 again to get the next point. So this puts me at 2 pi over 36. And then add another pi over 6, but remember, pi over 6 is really 6 pi over 36, right? That puts me at, so add 6 pi over 36 puts me at 8 pi over 36. Add 6 pi over 36 again. 8 plus 6 puts me at 14 pi over 36. They just said 1 period. 1 period is 5 points, so I'm going to do one more. Puts me at 20 pi over 36, okay? So I'm just going to do those 5 points right there. Now, we're doing a sine function, so that means I'm going to start out at 0, and then the a value is 4, so 0, 4, 0, negative 4, 0. And then the downshift is 2 units. So I'm going to do a third row for the vertical shift, and I'm literally going to subtract 2 from each of these values. So it's going to go negative 2, 2, negative 2, negative 6, and 2. If we were to do more points, it would follow the exact same pattern. So, I'm sorry, this should be negative 2. So negative 2, 2, negative 2, negative 6, negative 2. What would the next point be? It'd be 2, negative 2, negative 6, negative 2. That would be the pattern if we were to continue. But we'll just do the one cycle for now. So notice it starts out at negative pi over 9. So that means I'm going to start over here on the side of the graph at negative pi over 9. The next key value would be at 2 pi over 36, and then 8 pi over 36, and then 14 pi over 36, and then 20 pi over 36. All right? So my highest value is at positive 2. We'll say right here. Let's see. We've got a key value at negative 2. Keep going. We'll go down here to negative 6. We'll go like this. All right. So at negative 9, or negative pi over 9, we start out at negative 2. That's where the graph starts. At 2 pi over 36, we're going to go to positive 2. At 8 pi over 36, we're going to go to negative 2. And then at 14 pi over 36, negative 6. And then at 20 pi over 36, we're back at negative 2. So again, I know these numbers are a little bit uncomfortable, but if you follow the pattern and you're really careful about your numbers in your table, you should have no trouble getting these every time. And that's one cycle for this particular function. Notice it started out at negative pi over 9. That's your vertical shift to the left, pi over 9 units, rather than starting out at the origin.